Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends. In this video, we will write a program in assembly language for 8051 microcontroller to find out the maximum or the largest number present in an array of numbers. We are given an array of numbers, means suppose 10 numbers are given to us, and we have to find out that out of those numbers, which number is the maximum or the largest number in the array. So let's start with our program. Let us first see the program statement for this. So the program statement is that we are given an array of n numbers. Okay, then we have to write a program in the assembly language programming of 8051 to find the maximum number amongst the n numbers. So after those n numbers, we have to find out that which number is the maximum or the largest number. Okay, and we have to write this program for the using the instructions of the 8051 microcontroller. Then we have to assume that the length of the array, that is this n value, it is stored in register R0 of register bank 0. In 8051 we are having 4 banks, bank 0, bank 1, bank 2 and bank 3. So out of these 4 banks, the bank 0, its register number R0 is having the n value stored in it. Okay. Every bank is having 88 registers R0 to R7. Okay, so here register bank 0, and of that bank the R0 register is used to store the length of the array. It is already stored there. Okay, also we have to assume that the array, that the location from where the numbers are stored, the location at which the numbers are stored is the starting memory address is 3000H. Okay, now the result, that is the maximum or the largest number, that result is stored in register R1 of register bank 0. So again bank 0, but now its register R1 is used to store the result. Okay, so let's start with our problem. So first of all, we will see that what are the things which are given to us. So first thing which is given is the length of the array. So we will initialize a pointer to point these numbers, because all the numbers are stored from the 3000 memory location, and how many numbers are present that is stored in are not register. So we will use a pointer to point to these numbers. Okay. Second thing, now we want to find out that which number is the maximum number. So what we will do, we will start comparing these. Suppose there are 10 numbers, 01, 02, 03, 04, 05. In this way there are 10 numbers. So what we will do, we will first compare these two numbers. Out of these two numbers, which is the maximum number? 02. So 02 is the answer. Then we will compare this with the third number. Out of these two, which is maximum? 03. Now this number and next number will be compared. Out of these, which is maximum? 04. So answer is 04. Now 04 and 05 will be compared. So in this way comparison will be made. So what here we are doing, we will compare the first number with the initial maximum number, that is 0. We have initialized that the maximum number is the 0 value. Okay. Now we will compare, every number will be greater than 0 or either it will be equal to 0. Okay. So we will first compare the first number with the 00 initial maximum number. Out of them 01 is the maximum number. So 01 will become the next maximum number. Now this number will be compared with the second number. So in this way comparison is made. Now if in these two, the number, that is the first number, if it is greater than the maximum number, suppose we have find out that this 01, this first number is maximum to with this initial maximum number, then save this number. Otherwise compare increment pointer to compare the next number. Suppose that it is like first number is 01, next number is 02, and again the next number is 01. Okay. So 01 is compared with 00, which is the maximum number, 01. Now 0102 is compared, which is the maximum number, 02. Now 02 and 01 are compared, which is the maximum number. Already 02 is there, so it will be skipped and the pointer will be incremented, means no changes will be made in the maximum number and next number will be compared. So in this way we will do the comparison. Whenever the number which we are comparing is maximum, then the already maximum number, then this new number will become the new maximum number. Okay. So every time we are getting, after the comparison, we are getting the maximum number among these two. Now when this first comparison is being done, okay, first comparison is being done, then what we have to do, we have to decrement this counter, because we have initialized this R0 as the number of elements in the array. So suppose there are 10 elements. Okay, so first comparison is being done, so we have to decrement it. It will now become 9. That remaining numbers are 9 numbers. So what we will do in the next step, decrement counter. Okay, and again repeat this process, because now the memory pointer which is pointing towards these number, that memory pointer will now come to the next number. Okay, and this comparison will be done till all the numbers are compared. Now when all the numbers are being compared, so the maximum number, okay, that maximum number will be in the accumulator. Okay, we are having the maximum number, so that maximum number is to be stored in register R1 of register bank 0. It is given to us in the question. So store maximum number in R1 register. So these are the steps which we will follow to write our program. Now let's replace these steps or represent these steps in the form of a flow chart. In flowchart, our first step is the start process. From here, the flowchart will start and it will be shown always in the oval shape. Then next step is in the explanation I have said that first of all the length of the array is stored in R0 register. Also we have to initialize a pointer to point to these number, and counter is also to be initialized because this counter will store this R0 register value that this much numbers are being stored here. So in the first step we will initialize all the pointers and the counters. Now, once the pointers and counters, memory pointers and the counter which is counting the number of elements, they have been initialized. So next will be we have to load that number, the first number, into the accumulator. Okay. So next is now here what we are doing, we are not initializing our maximum number with some value. What we are doing, we are having a register B. We are using a register B and register A. Two registers we are using. A register is the accumulator and B register is present in 8051. What we are doing, first number we are shifting in register B. Then in register A we are having the second number. Here we are having first number, here we are having the second number. Then we are doing the comparison between these two. Okay. Now in this comparison, if the two numbers are not equal to each other, so whether there are two conditions, whether A will be greater than B or B will be greater than A. There will be two conditions if they are not equal to each other. Now when A is greater than B, okay, always we want that in register B we are having the maximum number. So if A is greater than B, then we will exchange their contents. The number which is in accumulator, that will come into B. Okay, and if B is greater than A, then no exchange will be done. Okay, because already in register B we are having the maximum number. So our aim here is that in register B we always have our maximum number, so that in the last we can get our answer in the register B. Okay, so first we are loading the data pointer by the pointer OP1 and store it in register B. Means that in that array we are having various numbers. Okay, so the first number will be shifted in register B. Okay, so that will be this step. After that we will decrement our counter. Okay, because first number is already there. Suppose there are 10 numbers, first number is already shifted in register B. Now it will be -1, that is 9th number, that is the second number will be shifted in register B. So next step will be counter equals to counter minus 1. Now after that we have to check that whether the counter has become 0 or not. Okay. If counter is not 0, then increment this pointer. Okay, means come to the next side. Numbers, the length of the array is decreasing, but the numbers position is increasing. So increment. Next, we have to load this. We have to load the data which is pointed by the pointer into the accumulator. Second number will be loaded into the register A. After that, comparison will be done that whether the OP1 is equals to OP2, means register A and register B, whether they are equal to each other. This is OP1 in register B, and here the data which is loaded in accumulator, that is OP2. So comparison is being made. Now when they are equal to each other, so there is no need of doing any replacements. Okay, but if suppose that they are not equal and condition is that in register 2, that is in register number A, the number is greater than the number in register B, that is register A is greater than register B. So exchange of the contents is to be done. OP1 to OP2. Okay. Sorry, here it will be checked that whether the OP2 is less than OP1. Okay, means OP1 is greater than it. Now, OP1 is register number B. So, copy the OP1 to OP2, means in accumulator we are having. Then, next step is this you have done. After that, when you have copied this, again you have to repeat the process here. Again you have to load the number, again you have to repeat the process. Now at this point when counter is 0, then come to the last step where you have to store the result. And then we will have the stop. Now here if this condition is not fulfilled, means when if OP1 is greater than OP2, then you have to exchange the contents. Here also and here also, all these things will join with this and the process will be repeated. Okay, again and again you have to do the comparison. So what we are doing, basically we are trying that we can get our maximum number. We will do the comparison, we will check that whether in register B we are having the maximum number or not. Okay. Now let's write the program for this. Now in the question you can see that it was given to us that the starting memory location is 3000H. Okay, and this 3000H, it is in the external memory. Okay, now to point the external memory, we are having a data pointer in the 8051 microcontroller. Now to bring the data from the external memory to the internal memory, that is into the accumulator, we have the move instruction. Okay, so first of all, what we will do, we will initialize our data pointer with this value 3000H. So first instruction will be move dptr, and we are initializing the dptr with the 3000H value. Okay, next in dptr we will get 3000 because this is an immediate data, immediate addressing is being used, so whatever data is there, that will come into the register or the pointer. So in dptr we will get 3000H. Now the data which is at 3000H, because from here all our numbers are stored, so first number will be stored at 3000. So we want to move this first number into the register. Okay, so first number will be transferred into accumulator. Indirect addressing we are using because we don't want to move this 3000 into A. We want that the number which is at 3000, that number should come into the accumulator. So for that, indirect addressing is used. Now first number has come into the accumulator. Now we want that this first number should come in another register, register number B. So what we will do, move the contents of A into B. So now in register B we will be having the first number. Okay. Now next step will be, when we have moved this, okay, then we will decrement our array, because how many numbers are present here from 3000H up till which memory location we have stored those numbers. So that is the length of the arrays is stored in R0. That is already given to us in the question, that we have to suppose that length of the array is stored in register R0 of register bank 0. Okay, so here we will have to decrement this pointer because first number is already being shifted. Now we want to we are having the second number, so DJNZ R0, and it will jump to some other memory location that we will see later on. Okay, decrement and jump when it is not 0. Okay, this is the instruction in 8051. D is for decrementing, J is for jump, and NZ is when it is not equal to 0. Now next is next we want to do the comparison. Okay, in that flow chart we have seen that after decrementing the counter we are checking that whether the counter is 0 or not. When the counter is not 0, we are incrementing our pointer. Okay, so here our pointer is this dptr, so next step will be inc dptr. Okay, now after incrementing the pointer, we have to load the data which is pointed by the pointer into the accumulator. So next thing will be, again the data pointer is being incremented. Now it has become 3001. Next number, second number will be there. So now that second number is again shifted into the accumulator. So again we will write this instruction, move x a and indirect addressing dptr. So what is there? First number already shifted in register B. Now in accumulator we are having the second number. Now we will do the comparison. How we will use? We will use the instruction C, J, N, E, A, comma, B. This is an instruction in the 8051 which C is for comparison, J is for jump, NE is for not equal to. That means compare these two and jump when they are not equal to each other. Okay, means when A and B they are not equal to each other, then this is going to jump to some other memory location. That we will see later on that where it is going to jump. After that, when these two are not equal to, it means two conditions can be there. Whether A is greater than B or A is less than B. If A is greater than B and we want that in register B, we should always have our maximum number. But A is maximum in the first condition, so we have to shift this A into B. Okay, so shifting of A into B is here in this case. Also, when this instruction is executed C, J, N, E and we have found out that A is greater than B, then there are changes in the carry flag. Okay, when A is less than B, it is going to continue the process because in B we are already having the thing, so it is going to again. So when A is less than B, then the carry will be generated, means carry flag is 1. And when A is greater than B, then no carry is generated. Okay, so when this condition here, when comparison is done, then jump and not equal to means they are not equal to each other. There can be two conditions, whether A is greater than B or A is less than B. So in that cases, how we can find out that out of these two conditions which is possible, we will check the carry flag. If the carry flag is generated, it means that A is less than B. If carry flag is not generated, it means A is greater than B. So next instruction is we will use the jump instruction on carry. That jump on carry, and what we have to do when carry is generated means B is greater than A. In B we are already having our maximum number. Okay, so there is no need of doing exchange because in register B we want our maximum number only. So next we have to do is again decrement the counter and repeat the process. So jump on carry to L3 and L3 is written here. Okay, so when carry is generated, that condition will be when A is less than B. So what it will do? It will continue doing the comparison. It will decrement this R0, then it will come to the third number, then third number will be shifted into accumulator and that third number will be compared with the register B. Again comparison will be done, again it will be checked that whether the carry will be generated or not, and the process will be repeated again and again. Okay, now suppose that next, when here I have written that C, J, N, E, A and B. Okay, after that next condition can be that if no carry is generated, suppose that carry is not generated in that, so in that case A is greater than B. Now in B we want our maximum number, so we have to exchange their contents. So what we will do, when carry is not generated, then we will use a jump instruction, which is a short jump instruction, and where it will jump at this position. So here we will write L1 and L1 is written here. And exchange of contents is done. The number which is greater than in A, that is present in A, that will be moved into B. Okay, in B we will get the maximum number. Again the pointer will be decremented and process will be repeated. Now suppose that at this position D, J and Z are not, suppose that when we are decrementing our counter and we have reached that all the 10 elements are being checked, then what we have to do in register B, we are having our maximum number. So just we want to store that we have got the result in register A. So D, J and Z are not L2. And where L2 is being written? At this position, INC DPTR. Okay, means when it is not 0, what it has to do, it has to just come to the last position. Okay, so here we will write SJMP short jump STP, and STP is written as the label here, and move in register R1 we want our result, and in register B we are having the maximum number, so maximum number will now come into R1. So when all the numbers are being compared, then you just have to store the result, so just jump to this last step. Okay, now here also when we are comparing this, okay, and we want that when we are finding that they are not equal to each other, that is NEQ, and this label is given as here. Whether this condition can be there, or if they are equal to each other, suppose that the condition comes that A and B, they are equal to each other. So what you have to do, again you have to come to this position L3. So here also we will write a jump instruction as jump L3. Okay, so when they are not equal to each other, then check for carry. If they are equal to each other, then again repeat the process. So let's again understand this program. What we have done, first of all, we have initialized our data pointer with the memory location 3000H. Take an example also. At 3000H, we are having 54. This number is stored. From this memory location 3001, 3002, 3003 up till 3009, we are having an array of 10 numbers. Suppose that first number is 54, second is 45, then we are having 66, then 71. In this way, numbers are stored. So first 3000H, it is an external memory. We want to bring this number 54 into the internal memory, and in this internal memory we are having register A accumulator and register B, another register we are having. Now we will use a data pointer DPTR to point to these memory locations. Also we will use a register R0 to tell that there are 10 numbers in this array. So this pointer will run up till 10 numbers. First number 54, it will be shifted into register A. After that, this number will be shifted into register B, that is 54. Again, next number, this DPTR will be incremented, it will come to 3001. Again, this second number will be shifted to register A. So now this register A will have 45. Now comparison will be done between them. If these two numbers are not equal to each other, that is A and B, they are not equal to each other, then there can be two conditions, whether A can be greater than B or A will be less than B. If A is less than B, then carry is equals to 1, carry flag will be set. If A is greater than B, then carry flag is not set. That means it is 0. So at this position, we will check our carry flag. If A is less than B, in B already we are having 54. that is our maximum number. So there is no doing any replacement. Again repeat the process and do the comparison. If A is greater than B, suppose that in A we are having 45, A is not greater than here. In this case, if A is greater than B, then carry flag is not generated. In A we are having the maximum number, exchange the contents. Bring this maximum number into register B and repeat the process. So that is what we have done here. First A is shifted in B, then decrement and jump up till not 0. This R0, that is the 10 array numbers, that is not has come up to 0 value. If it has become 0, then do the last step, that is move the result into R1 register. Increment the data pointer, again move that second number into the accumulator, do the comparison. If they are not equal to, then check the carry flag. If carry is generated, then the problem is you have to continue this. So again jump to this and do the comparison. If carry is not generated, then exchange the contents. Okay, and then last store the result in R1 register. So this is the program with the help of which we can find out the largest or the maximum number present in an array. You just have to remember the concept that how we can use the instructions of 8051 to do the comparison, to find out that which number is greater. If the concept is clear to us and the steps or the sequence is clear, then we can easily write the program in the assembly language. So I hope that this program is now clear to you. Thank you.